we need to compute the area of the regions in the first quadrant enclosed by the three curves given as these formulas. So the first curve is a hyperbola. It should look like this, but we only need to care about the first quadrant. So now we graph it by, say we use 3 points to just sketch the graph. So we know that x equal to 1, y equal to 5. X equal to 5, y equal to 1. And x equal to y equal to square root of 5. So square root of 5 squared is 5, then we get x times y equal to 5. Root 5. So the part of the hyperbola in the first quadrant should look like this. This is y equal to 5 divided by x. The two other curves are actually easier. So these are the equation of lines. So here for the second curve, we just need to determine 2 points on the lines. So x equal to 0, then y equals 0. So the origin is on this line. Second one is x equal to, say, 1, then y is 3 times 1, so 3. 0, 0 is on the line, and the second one is 1, 3 is on the line. 1, 3. 0, 0 and 1, 3. So this is a line y equal 3 times x, and the last one is y equal to x divided by 3. So x equals 0, y also equals 0. So the origin is also on this line. And the second one is, say, x equal 3 equal to 1. So 0, 0 and 3, 1. So the point is this point. So this is the second line. This is the last one. Y equal to x divided by 3. And we need to compute the area of this region. To do that, so we will compute the coordinates of the intersection points. This point, and this point is the origin. So after computing the intersection points 1, 2, and 3 here, so we know for sure 0, 0 is. We know that this point is 0, 0. We will compute the coordinates of the two intersection points, and then we can cut this region into 2 parts and compute the area of the first part plus the area of the second part. So if, let's say, this is x1, y1, and this is x2, y2, we can compute that. So here we divided the region into 2 parts by this vertical line. So here's the coordinates. Here is x1 and here is x2. We will compute the area of this part where x from 0 to x1, and the second part where x from x1 to x2. Area of the total region is the area of the first region plus the area of the second region. Of the first region is computed as the integral of the blue curve minus the green curve dx, where x from 0 to x1 plus the area of the second region, which is the red curve minus the green curve dx, where x from x1 to x2. So now we just need to compute x1 and x2 and plug in this formula. X1, y1 is the intersection of the red and the blue. So the coordinates x1, y1 satisfy the equation of red and blue curve. So y1, x1, y1, x1. This gives us y1, x1 equal to 5. From the first equation, the second equation gives us 3 times x1 equal to 5. This means x1 squared equal to 5 divided by 3. So we know that x1 is square root of 5 divided by 3. This gives us y1 is 3 times square root of 5 divided by 3. 3 times square root of 5 divided by 3. So this is square root of 15. So we can bring this 3 into here to 3 square and divide by 3, we have 15. So x1, y1 is x1, y1 is square root of 5 divided by 3 square root 15. Y2 is the intersection of the red and the green curve. X2, Y2 is the intersection points of the red and the green curve, so it needs to satisfy the equation of both red and green curve. So this one gives us y2 x2 equal to 5, and replace y2 is x2 divided by 3, x2 equal to 5. We have x2 squared equal to 15. So x2 equal to square root 15. And this gives us y2 equal to x2, which is square root of 15 divided by 3. So y2 is square root 15 divided by 3. So now we can plug in this formula. The area of the region is from 0 to x1, where x1 is square root of 5 divided by 3. Here we have x1 is square root of 5 divided by 3, and x1 square root of 5 divided by 3. x2 is square root of 15. The blue curve is y equal to 3x, y equal to 3x, The green curve is x divided by 3. And the green is x divided by 3. The red curve is 5 divided by x. So here's the formula. Now we just need to do the computation. So the answer should be 5 times natural log of 3. So this is the area of the region.